Welcome everybody to today's SMPTE Standards webcast. Today's webcast is intended to provide everybody with an update of advancements in SMPTE Standards development. And the topic today that you can see on your screen is the Interoperable Master Format, better known as IMF. And we're going to talk about application number 2 and beyond. Glad you could join us today. I am your host, Joel Welch, SMPTE's Director of Education. Hope the sun is shining where you are. If this is your first Standards Update webcast, it's a quarterly series of 1-hour interactive webcasts. We do cover advances in SMPTE standards development. We try to pick the standards that are making the most progress, or ones that have a great implication to the industry. Different from our monthly educational webcast, these are free of charge to everybody. So we want to let everybody know just what wonderful work the folks who are working on standards are doing. So we let everybody in, and we will share the on-demand video of the session with everybody as well. Now, today's speaker is Ms. Annie Chang. She is Vice President of Post-Production Technology at Walt Disney Studios. She's also chair of 35 PM 50. And I'm going to give Annie control over the slides. And Annie, if all is working, the floor is yours.
Thanks, Joel. And I just wanted to thank SMPTE for giving me the opportunity to speak to you guys about IMF today. As Joel had mentioned, let me just see here. Okay. As Joel has mentioned, we're going to break this up into 2 parts. The first part will be basically talking about some general IMF background, but I figured that we should probably level set and make sure everyone's understanding what IMF is all about. Then we'll stop and take some questions, and then we'll talk a little bit about Application 2. What the heck is that? Application 2 Extended, yes, there is more. And then also what's in the future for IMF, and then we can take some more questions after that. So let's get going a little bit about what IMF is. Yes, IMF has many definitions, and in this case, it's the Interoperable Master Format is what we're talking about. Some people have actually considered this as the impossible mission force, but I can say we actually did accomplish some things. In fact, we have several standards that have been published since last year, and we're going to talk about those in just a bit. But IMF is really meant for post-theatrical masters, also known as home masters, and it's also really meant from a B2B standpoint, so not really to the consumer. IMF is loosely based on the digital cinema standards, but we do have sort of a broadcast twist to it. So basically, we took the pieces that we liked of digital cinema, and then we added some functionality that are needed by television systems, meaning different frame rates, different resolutions, and the key to the interoperability is that these standards are constrained, so that hopefully we have a good way to define them and then interop them. It is a single interchangeable master file format, but as you will see as we're talking, it is basically made up of a bunch of different files. But the key to IMF is that you don't have to store these long play versions of your content. Instead, you just store the deltas, and you have all these different versions, but just unique pieces of the assets. And this really gives you a true file-based workflow, so not just the equivalent of a tape, basically. So what do I mean by that? Well, you remember the days of HDCAM-SR and tapes and things, and it was such a lovely time. We would build our content, have some bars, maybe a slate, some black, and then your program would start. Maybe you'd edit in some commercial blacks. You'd have your texted material and maybe have textless at the end. So when we started going file-based, basically we did kind of the thing. We captured in that tape and we made files, and we were like, yay, we're all file-based. Well, actually, all you did was basically take what was on the tape and wrap it into some type of container, and you basically made a long play version of that tape, but it was a file, and it gave you some flexibility on how to actually encode and do some things with the file. But in the case of like perhaps you were making a ProRes QuickTime or maybe some MPEG-4 files, you saw the limitations of this method pretty quickly when you start getting to versioning. So if you had to do any edits or you had to do multiple language versions, you ended up having to create these long play masters, once again repeating a lot of the common pieces over and over again, but racking up basically your storage costs and the amount of files that you're creating. So this is where IMF is really cool. Basically, you just store each of these little unique pieces of assets and content, and then you have this little XML playlist that then points to the different pieces of content and builds up what looks like that long play master again. But instead, what you have are these discrete elements that you don't have to repeat over and over again. You just need to keep just the unique pieces. And so in this case, for example, like the commercial black piece, that little slug that I have there, is being used multiple times. Well, you only have to keep one instance of that and then have the playlist point and refer to that over and over again wherever you need it. And the playlist is XML, just so you know. So let's talk a little bit about how this structure works and how the different pieces of IMF. So the key to IMF really is this composition playlist, that XML that I was talking about. It's like an EDL or a recipe, and it basically points to these various track files to allow for synchronization and allow the proper playback of the content. It acts kind of like an iTunes playlist, which basically points to a bunch of songs, right, and sequences them for you. That's what this composition playlist does. The track files are your actual essence, so that could be image, audio, data essence, and even metadata. And these are all first-class citizens in IMF, so that's kind of important to remember, is that, for example, subtitling captioning is not a second-class citizen, it is a first-class citizen for IMF. And in the IMF world, we call subs and closed captioning data essence. So you basically have this composition playlist, XML, that points to these track files. The essence is wrapped in an ASO2 subset of MXF, which includes metadata. So that's how these track files are built. When you have the CPL and track files, you basically create a composition. And a composition could basically be anything that's a piece of content. So it could be a feature, could be an episode, could be an advertisement. It's whatever you want your full content to be. Outside of, so basically the composition playlist and the track files, that was basically borrowed from digital cinema. Now, outside of digital cinema, what we decided to add for IMF was something called the output profile list. And I'm going to go into more detail about the OPL in just a second here. But the OPL is used to give a set of global instructions to the composition. So you do something with it. It could be transcoding, or it could be just conversion parameters. You could take an HD and create an SD from it. So it has a list of instructions that you would use to act upon a specific composition. And then, just like in digital cinema, we have two files that you would use when you move these IMFs around. You have an asset map and a packing list. And together with all of these files, you would create an IMP, or Interoperable Master Package. The packing list is very similar to a packing list that you would get from a FedEx or a UPS shipment. You would have a list of basically everything that is supposed to be in that package, so you would know that, oh yes, I did get all the pieces that I need. It also includes a hash that allows you to check to make sure nothing got corrupted during the transfer. The asset map is very useful because what that does is it basically takes the files that are physically on or physically in the transfer. So perhaps you move the IMFs onto a hard drive and they're in different folders. The asset map takes those physical files and maps them to were actually located on the drive to their UUIDs. So the key to IMF is that we don't use directory structures. We use UUIDs to identify each of the individual pieces, and the idea is that the receiving system would register all of the assets for IMF so that it knew where it basically takes the assets and places them where it wants to put them, registers them, and then it can find them later. So that's the basic structure of IMF. I did want to talk a little bit more about output profile lists because the OPL standards were just published about a month ago, and so we're really excited to have these. It's just the start of OPL. We wanted to throw some standards out there for people to use, and then we could get some feedback about whether we're doing this the right way, or maybe we're off track or something. But we think we have a good thing here. So the OPL allows for the creation of output deliverables by using these instructions that you would then place upon a single composition. We have a couple of different OPLs. We have something called a preset OPL, which is basically just a simple OPL that just says, hey, whatever I have, just play that. Then you can have more complex OPLs. This allows you to manipulate the composition. You could start doing, say, some image scaling or cropping, routing audio, or perhaps encoding it into a completely different compression format and wrapper. So I have to thank Dr. Pierre Lemieux for the next 3 slides of pictures because he helped create these during the OPL development, and I think it helps to explain how the OPL works. But the OPL is made up of something called these macros and these instances of macros. Each macro is basically a processing step that has several parameters to it that lists out what needs to be done. And then you can string together several of these macros together into sort of a pipeline and order them so that the instructions happen at a certain sequence of events. Each macro is fully executed in turn, but the thing is that I'm just showing you this in a serial sort of way, but it doesn't mean that the processing for these actually have to happen in a serial fashion. You can parallelize the processing as it makes sense for the system. So each of these macro instances are identified also by a UUID. So the 2 main OPLs that we have right now, we have audio and image macros. The first audio macro that we created is this audio routing and mixing macro. And the idea here is that it takes the audio channels from these virtual tracks inside the IMF, and then you can combine them or route them to the actual output channels on a device, for example. So the simplest form would be, let's say in your IMF you have 5 different configurations. You have English 5.1 and English 2.0, French 2.0 and a French 5.1, and maybe an M&E 5.1 and a M&E 2.0. But let's say for this specific application you just need to take the English 5.1 and maybe the M&E 2.0. You could take that through this audio routing and then just send out those specific channels, the left, right, center, left surround, et cetera, to the specific channels out. In this diagram, we have a little bit more of a complex routing situation where we're taking like a 2.0 music and effects channel, music and effects configuration, and then a English dialogue, and we're routing them together to create a left and a right stereo output where the dialogue is actually being mixed into the M&E left and right. So that's an example of the audio routing and mixing. On the image side, we have a few things going on. Now, on the image side, we determined that we needed to be able to do image calculations in a common space. So we decided that we needed to create and define a reference image space for these calculations to be done. So you have a pixel decoder, which would take whatever image content that you have and put it into what we call this reference image pixel space. And there you can do your calculations. So you might have a couple different image processing on it. In the case of where we're at right now, we have image crop and image scale available for OPLs. And then you would then take that content and take it out of reference space and back into your output space, which then can then be wrapped into an MXF. So that's sort of the way the image macros would stack up and get sequenced for OPLs. So now what I want to do is, some of you may have seen these slides before. I use these quite a bit just from the standpoint that it seems to get the point across about how the versioning works in IMF. So now that we've talked about OPLs, let's go back and talk about the overall packaging and how you would create full packages versus supplemental packages. So in the case that I have here, let's say we have an English version of some content. It's got an English title, main video, and then English end credits. Then there maybe is English 5.1 and 2.0 audio, and then there's an English closed captioning track. There's a CPL that then points to all the tracks and sequences and synchronizes them for proper playout. If you create maybe just a simple preset OPL that says just play that, this could be your English IMP or your package there. So keep in mind what this package contains of these assets, you know, with all the different things, because we're going to refer back to it in just a bit. So now let's take a look at, let's say we have a piece of content, same content, but now we need to add French subtitles to it. So in the old days of file-based stuff, you would actually have to create a whole new long play master with the French subtitles either burned in or as a separate track. But in the case of IMF, you could create a CPL that points to all the pieces and points to those French subtitles. And then the thing is, though, is let's say we sent off that English package before. Well, since we already did that and all we need to do is create an English version with the French subs, then you could just send off a supplemental package or a partial package with the new CPL, the French subtitle track, and then have that CPL basically point back to the assets in the English package. And now I know there's confusion sometimes about whether the CPL is pointing back to another CPL, but in the case of IMF and digital cinema, it's really just pointing back to just the assets in that English package. So the CPL contains UUIDs that point to and refer to these different track files that you may have sent off separately. So in this case, you could just send just this small tiny package, and the receiver could then create the English with the French subtitles. So let's take a little bit more complex example. So let's say there's a French dub. So maybe it has French main titles, there's French end credits, and then of course you have to give credit to the folks that dubbed the audio, so it's a little bit longer. You have French 5.1 and 2.0 audio, it's a little longer. There's a new CPL that creates this French dubbed version that points to all the pieces, but once again, because we already sent off that English package, we don't need to send the common pieces again. All we need to do is just send the differences or the deltas, and then have the CPL point back to the assets that were in the original English IMP. Of course, if you wanted to send everything, you can. There's no reason you don't have to do supplemental or partial packages. You can do a full thing. And let's say in this case, we wanted to create a more complex OPL that takes this HD content and creates a standard definition MPEG-4, for example. So that OPL could point to any of these CPLs, or it could point to all three of them, and you could send this whole gigantic thing, if you want to anyone that you would like. And then the last example I have is the airline edit or a censored version. So let's say we have that English package again, but let's say there's in the airline edit there's a scene with a plane crash. You can't have a plane crash in an airline version. That would be bad. So let's say we want to edit that out, and basically all we're going to do is butt the video together, taking out that sequence, and then put the audio together. Well, since let's say there's maybe a snat in the audio, so we create a new crossfade for that section, and we should be able to just make a new CPL that points to all these pieces again. But once again, since it's common English content, then what we can just do is point to the crossfade and the assets in that English package, and then once again just send off this small little package for this censored version. And I should also clarify, I meant to say earlier that there is confusion at times that when you send an IMF package or an IMP, that you somehow wrap these files in some other wrapper, like as if it was zipped or tarred together. Just wanted to make everyone aware that IMF is actually individual little pieces of files, and the actual essence is wrapped in MXF, but then those are all kept separately, and you have your XML as a separate thing, and so each of those files are all just kind of separate. There's no zip wrapping around all of them. All right, so just to give you some real-world examples, we took a few of our shows and created IMFs just to showcase to see like how much savings could we have. So for a 30-minute episodic, if we were to do it in our typical ProRes HQ QuickTime, we would actually have to create 3 separate files, linear long play versions of that. Each of those are 43 gigabytes each, so the total would be around 130 gigabytes in size. But from an IMF standpoint, the total for the 3 languages is only 46 gigabytes, so it's almost a third of that. And what we have is basically the original English version is the largest, of course, but because there's only deltas that we're sending with the supplemental packages for the other 2 languages, you can send things that are much, much smaller. So for a 90-minute feature, for example, and so Frozen had a lot of inserts in it, as well as the different languages. So for the ProRes version, we had the long play versions were each 135 gigs each, and that totaled around 400 gigabytes. But for the IMF standpoint, it was more around 95 gigabytes in size, where the English version was about 85, and then you can see that the other 2 languages were smaller. And just to make apples-to-apples comparison, the IMFs here that we're talking about are the equivalent of the ProRes HQ QuickTime encode. So it's a 422 YCBCR in J2K. So moving on a little bit about now moving up to the general structure of IMF. Basically, we decided to take a modular approach to IMF. We had a core framework of documents that you'll see in just a little bit that has the basic structure of IMF that's common to all of these things that you'll see in a second called applications. This would include the CPLs, the MXF wrapping, and any kind of major constraints on any of the essence. But then we have these modular applications that can plug into the framework and allows for specific functionality. This allows you to choose different codecs, or you can choose different resolutions or frame rates, and basically allows the application user to solve different problems. And the key, because of it's an interchanging type of thing, you only need to be able to interchange as a manufacturer within an application. So not necessarily between applications, just within them. So in our case right now, we have a couple of applications, application 2 and 3, which have been published. Regarding the standards, we have all of these lovely standards that have been published, and I have to thank the entire group at 35PM50 for helping to get these created and made and pushed through here. These documents that are in blue are the core framework documents that I mentioned. So that's the core constraints, composition playlist, the MXF wrapping, and the common audio labels. The standards here in green are the applications. So we have 2 applications on the table. Application 2, which I'm going to talk a little bit more about in a bit, are the JPEG 2000 applications. And right now there's the HD and SD, and then the UHD version, which is application 2 extended. And then we also have the MPEG-4 Simple Studio Profile application number 3. And then, as I mentioned earlier, we just published 4 OPL documents that we're very proud about, and those are listed in yellow. So just a quick structure at SMPTE. So IMF is under the 35PM Technology Committee. There's a working group that I chair called 35PM50. We have several groups that are very active and have been winding down also and spinning up. So the Sample Material Interchange Ad Hoc Group is the one that's been the most active. And then they're tasked with tracking any kind of bugs and resolutions, and then feeding them back into any standards revisions. And then also they're in charge of the plug fests, and this is where we can test out the interoperability and also clarify any issues that we might have with the standards. So in the case of PlugFest, we have content owners that provide some source files. We have multiple manufacturers that attend with their products, and they create and interchange the files. And then we chat about any kind of issues that they found and give some real-time feedback. And as I mentioned, any kind of fixes that we need are incorporated back in. And we do have another PlugFest coming up in Los Angeles at the end of this month. The audio drafting group is just about to start spinning up again to talk a little bit about object-based audio. And the output profile list group is now winding down a little bit because they've done their initial drafts, or documents. And so we're going to wait and see how OPL is being handled in the real world so that we can then move on to other OPLs. Our current projects in 35 PM 50 are to take a look at the one-year revisions, because it's been a year now since many of these documents came out. So we're starting to take a look at any kind of clarifications or additions that are needed for these documents. And also we have another project, and I'll talk a little bit more about this in a bit. It used to be IMF Application 2 mezzanine film format, but I'll explain what happened with that whole thing. But it's basically an archive format with JPEG 2000. So to just finish up this last section, or the section about IMF, I just thought I would put out some cool things about IMF that you might know or you might not know. So content version, there's a piece of metadata in the CPL that you can use called content version list, and it allows you to put in any kind of identifier that you would like, including UUIDs and ISANs or IDER, or even your own asset inventory system identifier in there. Content version also can be used to track the versioning of your files. So if you had an error in the content, for example, and you needed to swap out some content and you want people to use this updated, say like a version 2 of the IMF, this is where you would actually put that versioning information in. Another cool thing that we are doing with IMF is getting the MXF metadata into the CPL. So now IMF CPLs can reflect the exact metadata that's contained in the MXF files. What a concept! So you can have things like resolution, color space, sampling rate, things like that, that are actually in those MXF files reflected in the CPL, so that your CPL playlist actually reflects what's actually in your essence. This is all done through an open source toolkit that's based on regXML, which converts that MXF metadata into XML. And the really, really cool thing about this is that it uses the published SMPTE metadata standards to go against. So anything that's added to the registers, the toolkit will catch, so that it automatically updates any new metadata that is included in the SMPTE registers. And the other cool thing is that the toolkit will generate XML schemas that can be used to validate those CPLs with. IMF also uses multi-channel audio labeling. So you remember those days in the HD-Cam SR days and tape days where you would label the tape with like what channel 1 was and what channel 2 was, and maybe it was like a 5.1, and you actually listed out each of those channels. Well, you could do that in a file-based manner using multi-channel audio labeling. And so that's something that a lot of people don't know is available in IMF. And the other cool thing about IMF, there's lots of cool things, but I just wanted to pick 4 of them, is the markers, which is a capability inside the CPL, which allows you to basically label and mark certain parts of your composition. So let's say, for example, in our lovely long play version here, which is actually made of discrete parts, remember, we have, let's say, the first frame of bars and tone, and we can label the first frame of the head slate, maybe the first frame of the distribution logo. You can also have the last frame as well, but I wanted to kind of make it a little cleaner here. And then we also have first frame of commercial blacks, maybe the last frame of the end credits, first frame of Texas material. There's a whole bunch of other labels that are available for use that you can label that. And then now they're labeled, you could have an automated system downstream do something with these, or jump into certain parts here just based upon the labels. So the opportunities are endless when it comes to what you can do with the markers. So now it's time for questions so far.
And we do have a few. The first, Annie, I think I know the answer to, but Will all NLE vendors adopt this for post?
Well, I have a little bit about the whole manufacturer side later, but we are hoping they will because this is the first, I would say, file-based standard that's available that allows for all this capability. And I think the key is that once companies and studios and all kinds of content owners are demanding this format, that really causes these NLEs and other manufacturers to take a look at it and say, oh yes, we need to do that. So Disney has been working with several manufacturers and a couple of NLE companies to get IMF working in their editing systems. So I would say yes. The question is, I think, from a time perspective, when they would actually be able to support it and publicly say they're able to manipulate the IMF files.
Thank you. Next question, and though SMPTE does not promote, endorse, or recommend equipment or company services, the question is, what type of hardware and software options are available for creating IMF at this time?
So there's actually several systems out there, and I didn't really want to put a slide with it because I felt like that was like, as Joel said, it seemed inappropriate to publish it. But there's several companies already offering IMF capability, and the thing is that there's different systems. There's creation systems, there's QC systems, there's compression and encoding systems, and then also just manipulation systems. So there's the Roden-Schwartz, also known as DDS. Clipster is a common one that's out there. Colorfront has their ability in transcoder. I'm just going to list these off the top of my head. Green International Consulting, GIC, has their DVP box that can create and manipulate IMFs. We have several QC capability. Interabaton and Archive Media and MXF for Mac can all play back IMFs and then do some QC capabilities there. And I know I'm missing a few, but also I do know that there will be some announcements. Telestream also has a capability for IMF. And then at NAB, I believe there will be several announcements from different companies as well supporting IMF.
Thank you. And we have several questions in the queue, but this next one I think will be the last one for this break, and then I'll hold the others till the end. But this is a very good question, I think. Does IMF have any native anti-piracy forensics, or is this the domain of individual content owners and/or third-party providers? For example, being able to identify where a leak may have occurred in the digital supply chain.
That's a very good question. So IMF really is a file format. So there was some key tenets which I didn't cover in this one, but I think I actually covered in the original IMF webinar back in 2012. And so what we were trying to do as the IMF proponents was to basically create this file format that was very flexible in how we do versioning. To answer your question, the forensic part really is meant from a third-party standpoint, and I know that there's Civolution has I don't know if it's I know that they're working on, or I'm not sure actually if it's announced yet, but they have a way to work with IMF as well. So we're expecting that there would be third parties that would be providing that capability, because once again, it's a file format, so the idea is to use it the way you would use other files. And so IMF itself doesn't have any tracking capabilities in that sense. But you can watermark it, and you can do the things that you would do with other file formats that are out there. And I'll just leave it at that for now.
Thank you. Great. And let's hold the last several questions for the Q&A period. So I guess we can proceed.
Okay, thanks. This last section is pretty short, so we can get back to more questions in just a bit here. Going now into the applications. So the core IMF that's common between all of the different applications is listed here. You have 24-bit PCM audio. You can have any number of channels and any number of configurations that you would like to have in there. The subtitling and closed captioning is using SMPTE time text, also known as ST2052. And the wrapping, as I mentioned, is using the AMWA ASO2 constrained MXF. And as we've talked about, the composition playlist is the playlist that's used, and that's XML based. When it comes to application 2, however, in addition to the IMF core, we're using JPEG 2000 broadcast profiles. These are have been created by the ISO IEC. You can see the standard down below, 15444-1. And application 2 allows for both lossless and lossy compression. Now, the basic IMF application number 2 was a very, at this point, kind of low-level version of what we really needed at the time. So it allows for SD and HD resolutions, 601 for the SD, 709 for HD, allowed for 8 and 10-bit bit depths. And then RGB and YCBCR, and then the normal frame rates that you would use from a broadcast standpoint. Also allows for both mono and 3D stereo, left and right eyes. Application 2 extended extends application 2. So basically you include everything that application 2 can do, but you also are now including up to UHD resolution. The colorimetry now includes 2020 and XBYCC. Again, it's still 8 and 10-bit. And in this case, for IMF application 2 extended, it's only YCBCR at these 5 frame rates that are listed below. And that was really to allow for UHD support. The reason why we limited the application 2 extended document to just what you see here is all of this was what is basically allowed for in the current version at the time of 15444-1. So you could basically go up to UHD 422. 10-bit, and this actually helped the needs of a few companies like Sony Pictures, for example, that needed to transfer their UHD content in IMF and have it in a standardized format. But you might be asking yourself, what about these other crazy things that are coming down the pipeline, like 4K and HDR and 16-bit and everything, including the kitchen sink, and 8K? Well, what's cool about IMF is that we're trying to make it so that it's future-proof and extensible. Sorry, losing my mind here. All right, so the application 2 roadmap, and thanks again to Pierre Lemieux for creating this originally to explain things. We basically have time going from left to right, and you are here today where that blue line is showing. But we're done with application 2 extended, and the idea here now is to extend it out to these other new formats. So the idea here was to take application 2 extended and then create another version at some point that would be extended plus, and that would add true 4K resolutions in RGB and 12-bit. And then when the standards are ready, create an extended plus plus, which would add HDR support, including the PQ curve and some of the mastering metadata that was being standardized at the time. However, now because of the one-year review for application 2 extended, we are taking a look to see, like, well, maybe we don't really need to have these 2 extra versions that are coming out later, because we do have standards created for HDR support, thanks to SMPTE. The PQ curve is ST2084, and the mastering metadata is 2086. So we are taking a look to see that for the one-year review, that maybe what we'll do is, in addition to adding the true 4K resolution in RGB and 12-bit, just adding the HDR support in this document and just folding it all into one revision. And that would be the extended 2015 version. The other thing I had mentioned earlier is that the mezzanine film format, which was the archive version of with JPEG 2000, that originally started out as an application number 2 because it was JPEG 2000. but there's differences enough between the core application 2 and this mezzanine film format that we decided in the group that it made more sense to just create a separate application for the mezzanine film format altogether. So they're actually going to be the next application, which is number 4, and they're now on a separate track. So it's no longer having to be tied to application 2, although application 4 can refer to things that are in application 2 and application 2 extended. So this mezzanine film format supports up to 8K resolutions, includes XYZ, for example, and also 16-bit. So like I said, it was different enough from the application 2 and application 2 extended where we thought it would make sense to have it as a separate application. And the reason why we can do all of this with Application 2 Extended 2015 is that ISO also added new JPEG 2000 profiles for IMF specifically that it does allow for up to 8K, includes high frame rate, there's also higher bit depths and everything. So that's actually allowing us to include all of these higher resolutions into this Application 2 Extended for this year. But this is still under discussion, so we haven't completely resolved whether we are going to do this or come up with a different method of rolling out the standards. So in the short term, as I mentioned, we're taking a look at this extended revision to include HDR, 12-bit, and possibly 16-bit, and also true 4K with RGB. Also, in the short term, we're taking a look to see if perhaps taking 2052 and constraining that a little bit more, because SMPTE does allow you a lot of flexibility, and sometimes that can be a bad thing. So we're taking a look at the W3C's constraint that's called IMSC1. And that's what we're going to be using in the next PlugFest to see how people are handling that constraint on time text. And as I mentioned earlier, and kind of sort of addressing sort of one of the questions that mentioned, interoperability. We really need tools to support IMF. The standards were published last year. It is a brand new file format, so it does take some time to get some manufacturers going with this, but I'm hearing some really good groundswell for support on IMF, and like I said, there are a lot of manufacturers that already support it, and I foresee that there will be a lot more companies coming on board supporting IMF and giving it some capability there. And then also in the short term, we'd like to see what do people think about OPL now that those standards are published. Try testing it out. Does it make sense? Any kind of issues that we find or clarifications that are needed can be addressed in the one-year review. In the long term for IMF, new applications. There's no reason why you have to stick to the applications that are there. All you need to do is get a group of proponents and create a project as SMPTE, as long as you volunteer to do the work, because that's the key, because nothing gets done for free there. You gotta do the work. But then if you just write the standards, you can create another application. So you could be the one to do application 5. We already have a framework of documents that you can use to reference, so it's a lot easier than having to build this from scratch, I can tell you that. So that's something to keep in mind for anyone that's like, I like this IMF flexibility, but I'm not too big on whatever for application 2 or 3 or 4. So let's say you want to use HEVC or H.264, you could create a new application for that and just use the core framework and all that. Dynamic metadata is another thing that we would be taking a look at for IMF. There is some work going on for ST2094. That's the dynamic metadata for color transforms of HDR and wide color gamut images. There has been some talk about including that in IMF. And then there's been talk for many years about adding in pan-scan metadata, also possibly script and other descriptive metadata. So dynamic metadata is basically any kind of metadata that changes along the timeline of the program or composition. So there's been a lot of talk about just adding that in, but we haven't really focused on it very much, but I see that coming up probably in the next year to 2 years here. And then also some chatter about whether we should be including the metadata that would go with object-based audio I know my secretary for 35PM50 hates that term, but we don't really have another way to describe it. So also known as immersive audio. And then the last thing is more output profile lists. We intentionally left out the ability for an output profile list to do compositing and alpha channels and that sort of thing. It doesn't mean you can't do it. It's just we wanted to hold off on it because we wanted to put out those OPL documents that are out now, just so that people could test them and see how it is, because it is a new concept. And so we figured let's throw something out there that people can try to use and then see how the things are taken and whether we're on the right track or not. And then, of course, from a long-term perspective, talking about creating OPLs that will allow for transcoding capability and that sort of thing. So let's say you have this composition, you need to make this iTunes profile, you would create all that information into an OPL and then put that in with your IMF. So that is all I have for you. Hopefully this was informative for you, and we can now take some questions, and hopefully I have some answers for you.
And we do have some questions in the queue, but I do have to say, wow, Annie, great time management. We are exactly where we're supposed to be.
Yay!
Yay! The first question comes from SMPTE friend Nancy Wilkerson, sorry, and I think you may have answered some of her question, but maybe not. Does IMF CPL OPL include mapping to time text, AFD, bar data standards? For instance, ST 2052 and ST 2016, or is it constrained in MXF ASO2? And she says, thanks, Annie.
Ah, yes. Hi, Nancy. We'll have to get together sometime. So let's see if I can remember everything you asked for. So yeah, obviously I think you probably heard already that it does refer to 2052. So and as I mentioned before, SMPTE time text is a first-class citizen in IMF. So you can refer to those track files. The CPL does have an AFD capability in it. There was one more thing she asked for. What was the other, Joel?
Time text.
And yeah, so we addressed the time text. There was something else. So there's a bunch of active image and positioning information in there. So if you take a look through the composition playlist and the core constraints document, both of those have a lot of information about how to deal with the active image and the sort of transformations for those and cropping. So hopefully that answers her question.
Thank you. DB asks, do markers support multiple layers or categories?
Multiple layers. We might need a little bit more information on what he means by layers.
Okay. DB, if you wouldn't mind. And also you could always ask a verbal question. And
yes, let's do it verbally, DB. Come on.
Let's do a verbal question. Anybody can ask one. Let's see. Next question is Brian asks, how has HDR been incorporated, or has it yet?
It has not been incorporated yet, and the truth of the matter is just based upon the fact that there really weren't any standards available. But as I showed in the Application 2 roadmap, it is under discussion right now whether or not to incorporate in the PQ curve, which is ST 2084. We've already had a small group discussion from an Application 2 extended standpoint to go ahead and include the dynamic metadata for HDR images, which is 2086. That makes it, sorry, not dynamic, sorry. Oh. Whoa, I'm going too fast. The 2086, which is the mastering metadata. Sorry, it's a static metadata for mastering displays. We've already discussed that makes sense to go ahead and include that in the App2 extended revision. But yeah, right now we're just talking about whether it makes sense to include the PQ curve at this point or to try and figure out another way to do it so that it doesn't confuse the standard too much. But yes, HDR is completely under consideration. It makes a lot of sense right now, just because the biggest pain point that I find with HDR masters right now is that we are having to move around 16-bit TIFFs. and which is just way too much data. It's just ridiculous. So IMF can solve that problem by just incorporating in the HDR content into it, and then we'll be set, and we have a nice, much smaller set of files to send around for HDR.
Thank you. Angelo D'Alessio wants to know, what is the relationship, if any, between Digital Cinema Naming Convention and IMF?
Somebody had to ask that. I'll get on my soapbox here. So the Digital Cinema Naming Convention, which I am sadly, and nobody knows this, but I am the mother of, because we started it at Disney, was actually built because a long time ago, and apparently now, we have something called HAM, Human Asset Management. So we need the ability to read the name of the file and get everything try to understand everything about that piece of content from the file name. It's a really bad way to do things, the thing is that I have been asked whether we are planning to do an adoption of the Digital Cinema Naming Convention for IMF. What I'm hoping to do with IMF, there is no necessarily any need to create that naming convention for IMF, because what I'm hoping that we'll do is we'll actually get to a real file-based workflow where systems will be aware of what they're getting, and there is annotation text and that sort of thing that's borrowed from digital cinema so that you can identify your files in the actual file. So the idea is, instead of using or putting everything in the kitchen sink into the file name for IMF, there's metadata fields that you can put into the CPL, which then a downstream system can just read in and ingest, and that's actually the proper way to do the naming. It doesn't mean you can't use a naming convention or the digital cinema naming convention. I kind of imagine people are going to use that for a little bit with IMF, but I am hoping, as the mother of IMF, that we'll get away from the file naming convention and actually go with the metadata inside those files.
Perfect. Nancy has another question.
Okay.
Is it intended to be able to play, to air, or stream directly from IMF, or is a business required to unwrap and compile before playout? Can automation systems just play it back?
Good question. So IMF really was meant for a store and forward method. So it wasn't really ever meant to be something that you would do capturing in live. And I know this is so slightly different than our question, but just kind of addressing the fact that it's not really meant a live to air type of format, because we really were trying to fix the fact that you have all these versions that you're storing and you need to, try and keep down the file sizes. So it doesn't mean that you can't use it to stream from or to use from. I mean, if your system can take the IMF and play it out or stream it or do, even if it could do a live to IMF thing and then play it out, that's fine. But the original key tenet of IMF was really meant from a store and forward standpoint, and not necessarily for those type of applications. But there really isn't there is no reason why you couldn't actually stream this to a consumer if your system allows you to do that.
Awesome. Let's see. It's either Stefan or Stephen, and I apologize. How does IMF standard handle video overlays or green screens?
Yes. So as I mentioned sort of towards the end, we sort of have kept the compositing element away. The idea is we were planning to always have like a way to, say, overlay subtitles or burn-in or bugs and things like that on IMF. Right now, there is no OPL that can do it, so what you would need to do is have the system that you're playing back the IMF or working with to allow you to add in those burn-ins or place the subtitling in there. So just keep in mind, IMF, just because it's not there doesn't mean a third-party manufacturer can't just create the capability to allow you to do that. So the idea, like say in the Adobe Premiere, for example, if they're taking on IMF, you could still lay in overlays and things like that on top of that. Eventually, once we get some more feedback, I think on the output profile list, we're going to tackle the compositing and alpha channel question and really try to detail that out in an OPL. But like I said, if just because there's not an OPL for it doesn't mean you can't do it with some sort of third-party system.
Thank you. Another SMPTE friend, Josh Derby. He asks, Annie, is IMF open to adding other potential codecs beyond J2K and SSTP? Would that require new application profiles?
Yes, it would. Josh, yes, you can add more codecs if you would like. That's the cool thing, because I could have put that in as one of the cool things about IMF, is that it's extensible in the sense that you could create another application that has another codec. Doesn't have to be J2K, doesn't have to be MPEG-4 Simple Studio Profile. As I mentioned earlier, there's, if you wanted to do HEVC, for example, as long as it can be wrapped in the MXF generic container, you can put it into IMF. That is the key. So the thing is that it has to be a standard that the codec has to be a standard in order to be put into IMF, because you can't really put a non-standard into a standard. For example, ProRes I know is a popular one, and I've been asked, like, can you put that in IMF? Until Apple actually standardizes ProRes, and there's a mapping for how you would wrap that in MXF, you wouldn't be able to really put that into IMF. But then any other standardized codec that's out there, like H.264 or 5, can be put into IMF as long as it meets all of those core constraints that are set forth in the core framework for the IMF documents.
Let's see. Brian Beard asks, does application number 4 correspond with AXF, or is it disparate?
Oh, it is disparate. It's really meant for taking the cinema masters. It's kind of a hybrid between digital cinema and the broadcast IMF sort of world. So it's really just looking at the essence and then just creating a playlist around it and some wrapping and that sort of thing. So that's a very good question about how IMF works with AXF. The way we envision it is that you would actually put IMF into an AXF, if that makes sense. So they're not competing at all. So this also includes for application 2 as well. There's no reason why you can't do application 2, 3, or 4 into an AXF. And then AXF it also allows for that cool thing. I think that they still allow for spanning over multiple devices and stuff. IMF obviously doesn't span. It's just a file format. So you can use the IMF in conjunction with AXF.
Great. And our last question, this is from Axel. Is there a true 12 or 16-bit RGB mode as of now to use it as a native archive format for assets that need at least 12 or 16-bit, or is that only proposed for the future versions?
So this application 2 extended 2015 that we're talking about is the one that would actually allow for 12 and 16-bit J2K. So yes, it's not out exactly yet, but we have some drafts that we've been talking about, and the only thing that we're contemplating right now is whether to add that HDR in there or not. So that would probably be the one that you would want to use. And then depending on whether it was XYZ or RGB content, you could use application 4 if it's XYZ, for example, to store your content in, because that's a lossless and it's meant for an archive standpoint.
Great. And it is the top of the hour. Annie, as always, outstanding presentation. Thank you. I appreciate the excellent time management. Great job. And to our guests, I want to thank you for taking time out of your schedules to be with us. And to Bruce Devlin, yes, I will organize it soon. I won't tell you what the question is. I'll just tell him yes. So thank you to you, Annie. Thank you to our guests. This, as I said, has been part of the quarterly SMPTE Standards Update webcast series. And next time we will be talking about DCPs. Thanks, everybody. Have a good day, and we'll see you next time. Take care. Thank you, Annie.
Thank you.